When we're talking about M2M, machine to machine, really what we're talking about is an area of communications that's just generally called SCADA. And SCADA really stands, it's an acronym, it stands for Supervisory Control and Data Acquisition. And SCADA is just a general category of communications where machines are being used to control other machines and to supervise other machines. When we look at SCADA, the principal application for SCADA is really the measurement and control of various systems, particularly remote systems. For communications, particularly for satellite, we can either be providing primary connectivity, or in many cases we're actually providing backup cases, and that's due to security requirements where it's very important to have very high availability networking for these types of connections. Some secondary applications in the SCADA area is security and remote access. Security in the sense of monitoring the integrity of the pipeline, looking for intruders or looking for anybody who's trying to do harm. And then remote access is where technicians come into, maybe it's a pipeline location in the middle of nowhere, and they can use the communications to gain access into corporate headquarters to download documents, technical information about the pipeline or whatever the remote point is. So there's principal applications, and then there's secondary applications that we see with SCADA. When it comes to these SCADA networks, some of the key requirements, they have to be very highly available. It's no use if the network is not reliable. Geographic coverage means that these networks need to be able to have very good coverage over a very wide area, and that's because oftentimes these SCADA applications are deployed in the middle of nowhere. Again, think about a pipeline. That's the classic environment where we're putting in SCADA connectivity to support SCADA applications, pipeline and utility power lines. Then beyond that, some other things such as environmental stability, which means that as these units are out in the middle of nowhere, they're going to have to suffer extreme temperatures and extreme environmental conditions. These units have to be able to have very good and predictable response times or very good network performance, so that if there is a fault, the response can be delivered in a very consistent and timely fashion. And then finally, economically, these SCADA solutions, obviously, much like everything else, needs to be cost effective.